Hey everyone, welcome to our channel. Today we are diving into one of the most important and beautiful equation of the mathematics, that is Euler's formula. So in this video we are proving this formula using the Taylor series expansion. So let's start it. Euler's formula states that for every real theta, e to the power iota theta equals cos theta adding iota times sin theta. Now let's see the proof of the formula. So firstly we have to recall the Taylor series expansion of the exponential functions and trigonometric function. For e to the power x, the Taylor series expansion is 1 plus x square upon 2 factorial plus x cube upon 3 factorial plus x to the power 4 upon 4 factorial plus x to the power 5 upon 5 factorial and so on. For sin x, it is x minus x cube upon 3 factorial plus x to the power 5 upon 5 factorial and so on. For cos x, it is 1 minus x square upon 2 factorial plus x to the power 4 upon 4 factorial minus x to the power 6 upon 6 factorial and so on. These are the Taylor series expansion of trigonometric and exponential function. We will use these expansion to prove the above Euler's formula. So firstly we have to do is taking the expansion of the exponential function, which is e to the power x, we will put x is equals to iota theta to get e to the power iota theta. So when putting x is equal to iota theta, we will get e to the power iota theta equals 1 plus iota theta plus iota theta through the square upon 2 factorial plus iota theta to the cube upon 3 factorial plus iota theta to the power 4 upon 4 factorial plus iota theta to the power 5 upon 5 factorial and so on. Now before solving the powers of the iota, we need to know the powers of values of powers of iota. So here these are the values of the powers of the iota. Iota to the power 1 equals iota to the power 2, which is iota square, equals minus 1. Iota to the power 3 equals minus iota, and iota to the power 4 equals 1, and iota to the power 5 equals again iota. So now let's put the values of the iota in the expansion. We will get e to the power iota equals 1 plus iota theta plus iota square will become minus 1, so we will get minus theta square upon 2 factorial minus iota cube will become minus iota, which will be iota theta cube upon 3 factorial plus iota to the power 4 will become 1, so we will get iota to the power 4 upon 4 factorial, and again iota 5 will become iota, so we will get plus iota theta to the power 5 upon 5 factorial and so on. So we have got the left hand side of our formula, which is e to the power iota theta. So now we have to find out the value of sin theta, sorry, cos theta plus iota sin theta. So to get this term, we have to put x is equals to theta in the expansion of the cos theta and sin theta, and multiplying the iota with the expansion of the sin theta. So firstly we will put x is equals to theta in sin x and cos x. So we will get cos theta equals 1 minus x square theta square upon 2 factorial plus theta to the power 4 upon 4 factorial and so on, and you will get sin theta equals theta minus theta cube upon 3 factorial plus theta to the power 5 upon 5 factorial and so on. Now multiplying the expansion of sin theta with iota. So we will get iota sin theta equals theta iota theta minus iota theta cube upon 3 factorial plus iota theta to the power 5 upon 5 factorial and so on. So now to get the term cos theta plus iota sin theta, so we will have to add this expansion and this expansion. So we will get the value cos theta plus iota sin theta. So cos theta equals 1 minus theta square upon 2 factorial plus theta to the power 4 upon 4 factorial and so on, plus iota sin theta, it will be iota theta minus iota to the power 3 iota to the power 3 iota theta to the power 3 upon 3 factorial plus iota theta to the power 5 upon 5 factorial and so on. So we will get 1 plus this term iota theta minus this term theta square upon 2 factorial minus this term iota theta cube upon 3 factorial plus this term theta to the power 4 upon 4 factorial plus iota theta to the power 5 upon 5 factorial and so on. So we get the expansion as cos theta plus iota sin theta, and now comparing this expansion with the expansion of e to the power iota sin theta, we can see that all the terms of e to the power iota theta equals all the terms of cos theta plus iota sin theta. So from these two expansion we can say that e to the power iota theta equals cos theta plus iota times sin theta. This is our Euler's formula. Thank you.